Welcome into the section of the lab where we talk about VLAN trunks. If you'll recall from our slideshow presentation, a VLAN trunk is how you get traffic that's on the same VLAN to go between switches. If you don't have VLAN trunks defined between switches, then the traffic that's on VLAN 30 on the 2950, for example, would never reach VLAN 30 on the 2960 or on the VLAN breakout switch because the switches would not know where the other switches are located. Now, most modern switches, if you connect two switch ports to one another and they come up and they see that there's switches on both ends, most modern switches will automatically negotiate a VLAN trunk and start trunking every VLAN that's valid on both switches. However, if you'll recall the VTP lab that we just went through, you'll remember that I paused the video and then came back and said I had to manually manipulate trunking between the VLAN breakout and the 2960 in order to get VTP to work. And I promised I would pull back the curtain and show you what I did to make that work. And this is the part of the lab where I do just that. And in the process of doing that, we'll show you some of the commands necessary to set up trunks, to set ports to trunk unconditionally, and to validate that the ports you think are trunks are actually trunk ports. So the first thing we'll do is we'll look up here at the 2960 because it's got both types of trunks defined on it, one that's automatically negotiated and one that's statically set to trunk. So if we do show CDP neighbor, so we see which switches are on which switch ports, and we see that on this switch our local interfaces are Fast Ethernet 047 and 048. So what if I do show interface Fast Ethernet 0/47? Well, that just gives us the Ethernet statistics about the switch port. It tells us if it's up, if it's taking any errors, what the load on the port is, so on and so forth. It doesn't really tell us anything about the trunking or non-trunking status of this port. So what if we do show interface Fast Ethernet 0/47 and we put the switch port command afterwards? Now we get a little more information about how it's set up. It is enabled. Its administrative mode is dynamic auto, and we'll get into that here in just a moment. This is that DTP protocol that I mentioned in the slide deck that actually controls how trunks come up and how trunks are negotiated, and it should really be the VLAN trunking protocol in my opinion, but I didn't get to name the protocols. Its operational mode is trunk, and that's where you find out this is actually a trunk port. It's using the .1Q encapsulation. It is set to negotiate trunking. As you can see, it specifically tells you right down here, even though it is in dynamic auto, tells you the access mode VLAN, which is the default VLAN. It tells you the native VLAN, and you've got a bunch of other information about private VLANs and topics that we won't really get into here at the CCNA level. You see right here, we are trunking all VLANs on this switch through this port. And when we talk about spanning tree elsewhere in the course, you'll see how we can say certain VLANs only go out certain ports, and you can control how the traffic flows through your network based upon where your trunks are located. Now, at least for the 2960, most of that is the default configuration. For example, if we do show run interface Fast Ethernet 0/47, you see we have no configuration whatsoever on that port other than what's there by default. So let's look over here on the 2950. So we'll go into enable mode and do show CDP neighbor just to make sure that we have the right port on this end. And our local port ID is Fast Ethernet 048. Show run interface Fast Ethernet 0/48. Just to prove nothing up my sleeve here. Do show interface Fast Ethernet 0/48 switch port. You'll notice that this switch's administrative mode is dynamic desirable. And that's because the iOS versions are a little different between the 2950 and the 2960. Now, I point this out because when you study DTP for the CCNP, you'll find out that if the administrative mode is dynamic auto, like it is over here on the 2960, if it's dynamic auto on both ends of the trunk link, these two switches will never ever negotiate a trunk dynamically. They're always waiting for the other guy to initiate trunking. Auto basically says, well, I'll trunk if you want to trunk, but you have to start it first. And if they're both set to auto, the illustration I like to use is the little goofy gophers from the Warner Brothers cartoon, you know. After you, my friend. Oh, no, after you, my brother. Well, that's how these two communicate if they're both set to dynamic auto. The fact that the 2950 defaults to dynamic desirable, the 2950 sends the DTP packet that says, hey, I'll trunk if you want to trunk. And the other end says, well, absolutely, let's negotiate a trunk port. Now, such a thing doesn't really exist over here on the 2900. For example, if we do show CDP neighbor on this guy, we see that our local interface is fast Ethernet 0/1. If we do show interface fast Ethernet 0/1 switch port, we see we don't have dynamic desirable, and that's because I've manually configured this as a trunk. Let's look at fast Ethernet 0/2, and you'll see that it's set for static access, but if we do show run interface fast Ethernet 0/2, you'll notice we haven't specified that it is a static access port, but this guy doesn't support DTP, so its operational mode is static access unless you specifically configure it to be a trunk port. And this is one of the few cases where two Cisco switches connected to one another would never negotiate a trunk port. It's because the 2900 iOS doesn't support it. So now that we've gone through how to determine the switch port mode and determine which one will actually talk to another switch, we'll pause the video here and we'll pick it up in the next video where we talk about the commands to actually configure the trunking parameters on the interfaces.